This is a production of Cornell University.
Now, one can certainly imagine that if I look at a pile of dirt or soil in situ, here's a monolith, okay, that this is not pure sand, silt, or clay. There's a mixture of it. Okay? It's that mixture of these soil separates, sand, silt, and clay. It's the mixture of these soil separates that we actually call soil texture. Okay? I'm sure everybody has heard the term soil texture before, but these are the soil textures. And depending upon the combination of sand, silt, and clay, you will have a particular soil texture. Okay? These graphs, you basically read them up. This is clay, so this is 0 to 100% clay. This is silt, that's 0 to 100% silt, and this is 0 to 100% sand. Okay? You look at the arrows to follow which line path you're going to be following. So if you're looking at percent clay, you follow it this way. If you're looking at percent silt, here the arrows are pointing this way. Okay? If you're looking at sand, you're following it this way. You technically only need to know 2 of these to be able to figure out what the texture is. Imagine that I have 40% sand. Oh, I'll make it easier. 30% sand. This is my line for 30% sand. And I have 40% silt. Follow that line down. They meet right here. What's my texture? Clay loam. Does that make sense to everybody? Okay. Now, the combination of these textures thereof together basically make the textures. In general, the sandier soils are the coarser soils. They tend to be the sands, the loamy sands, the sandy loams. Okay, we go back to the texture triangle. Where do those guys sit? Sort of down here. And if you look at it, we're looking at 50% sand or more. Make sense? We follow this through the loamy soils. Loam is basically the moderate, the intermediate of everything, a mix of everything. Everything from the fine sandy loams all the way to the silty clay loams. Okay, when you get down into the clay loams, you're looking at predominantly clay dominated soils. Okay, go back to that textural triangle. The clayey soils up here, the silty soils here, the sandy soils here, the loamy soils in the middle. Make sense? This gives you an idea of what the particle diameter on. This is sort of geekish stuff, but just to give you an idea, just so you know that just because it's a clay doesn't necessarily mean it's 100%. There could be a mixture of it. It could be, in fact, up to 60%. And if we go back to the textural triangle, if I have 60% clay, I'm considered a clay. Okay, I don't have to have 100%. I could be 60%. There could be 40% of other stuff. In that scenario, the clay is so dominant that it doesn't matter if it was 40% sand. It is a clay. Now, to give you a sort of a little story to sort of give you an idea why this is important. In the 70s and 80s, the landscape people were working on ballparks, baseball fields in particular, and they were trying to increase the drainage of the ball fields. You can imagine if it rains and the ball field gets soaking wet and the water doesn't drain, it basically really screws the people that are playing the sports. Okay? So the thought was, well, if they're not draining, what should we do? Well, let's add some coarser material. So what they started to do is they started to add sand. What do you think happened to those ball fields? It actually got worse. Why? Besides the fact that we're making cement. But why?
I was going to say that you're making cement.
You're basically making cement. Well, think about it. What's going on here? They were not adding a lot of sand. They were just adding 20, 30% sand, thinking that that's going to make a dramatic change. Remember me showing you this slide before? Okay, these particles can pack a lot of different ways. If I have a uniform particle, same size, they can pack like this, or they can pack like this. But if I start mixing materials, these cracks can start getting filled. So imagine I put sand into this ball field. What's going to happen to all these little cracks? They're going to start getting filled up. And if I start filling up these cracks, the water's not going to flow anymore. It turns out that if you wanted to increase drainage in these ball fields, you'd have to add like 70 to 80% sand. If I've got this much volume and I'm adding 70 to 80% sand, my ball field is now this tall. That becomes a problem for a lot of ball field designs. Okay? That's why this is important. Okay? Questions? No?
This has been a production of Cornell University, on the web at cornell.edu.